All right, the next example is more general. The previous example was rather simple because the line passes the origin. So we are interested in a vector equation of the line which doesn't pass the origin. So let me pick some point P 0, 3, and then parallel to the line y equals 2x plus 5. So this line gives us the slope. So we are interested in straight line with slope 2 that passes point P. So straight line looks like this. So we want to find a vector equation for this. So, well, the idea is, so we want to collect terminal points to represent the line. So we want to find a vector equation so that if the collection of terminal points represents the line. So the idea is we will think of infinitely many vectors like this so that terminal points, the collection of terminal points will give you this straight line. Okay, so say we pick any point Q, then we are interested in vector OQ. So we can take any point Q be a point on the line, and we want to express vector OQ. Now that this straight line doesn't pass the origin, we need two vectors to express OQ. So we need to use this P. So this OQ is the sum of OP and then PQ. So this is OP and then PQ. OP vector is just a 0, 3. And then this vector PQ. Well, this vector PQ has a slope 2. So since PQ has the slope 2. Now it's time to pick a vector. So to express this vector with the slope 2, we need to pick a certain vector to express this vector PQ. So it's time to be kind of creative to find such a vector. Well, there are infinitely many. Now that this vector has a slope 2, you can pick any vector with the slope 2. So for example, 1, 2. This vector has a slope 2. That means you can take some scalar multiple of this vector 1, 2 to represent this vector PQ. That's it. Once you add them up, this vector will give you the vector OQ. And then let's simplify. If you add, we have 0, 3 plus t, 2t. So we have t, 2t plus 3. So t can be any real number. So this is a vector equation. So let me emphasize this. This is one vector equation. Well, this expression depends on our choice. Our choice of this point and our choice of this direction vector. So depending on your choice, you may end up with different expression, but all those vector equations are equivalent. So it might be a good idea to see how those vectors represent this straight line in terms of animation. So you can, in the PDF note that we provide, you can click this link, vector equation 1, vector equation 2, to see a GeoGebra example. So once you click those things, you will see some animated example where you can control the slide bar to move vectors and see how those terminal points represent this straight line.